Hi everyone, this is my video number 28. So I'll continue the lecture. In this video I'll talk on how to do conversion of boundary value problem into Freedom integral equation. Conversion of boundary value problem into Freedom integral equation. So we know that in the previous video we do a conversion of the initial value problem into the Volterra integral equation. Initial value problem into Volterra integral equation. Now boundary value problem into Freedom integral equation. First thing, you need to identify what is the initial value problem and what is the boundary value problem. Initial value problem normally giving at one particular point, and for the boundary value problem we give the condition at two different points. I would say two endpoints. Okay, so now let's see the example how to do this. We reduce the following. Reduce the following boundary value problem into integral equation. Into basically we got Freedom integral equation. Okay, we have d2y dx squared dx2 plus lambda y equal to 0 with the condition y0 equal to 0 and yl equal to 0. So if you look at this condition, we have different point of x. We have x equal to 0 and x equal to L. So this gives the indication that this is the boundary value problem. Alright. Okay, now how to solve this? Step is almost similar to the previous one, except here in this case, since we have two boundary condition with same y. Now from the given boundary condition we can write this, from the given equation we write d2y dx2 plus lambda y equal to 0 as d2y dx squared equal to minus lambda y. Then we integrate this, so let's call this equation as equation number 1, that's equation number 2, that equation number 3. Alright, so we integrate equation 3, we integrate 3 with respect to x from a 0 to x. Okay, from 0 to x, that we have integrate this, we have this give you y prime x minus y prime 0, that give you negative lambda integrate 0 to x yx dx. Since we don't have a particular condition for y prime x, so what we can do is we let y prime 0 equal to some constant c, where c is a constant. Then we need to determine c. Okay, from c, from that value of y prime c, let's call this equation number 3, number 5, 1, 2, 3, 4. This one is 4. This one is 5. Okay, 5. Okay, so use 5 in 4. So what we can do is basically we substitute just that. So we have y prime and bring it to the right. What we have is that y prime x is equal to c minus lambda integral to x y to x dx. Okay, so let's call this 5, 6. Alright, now we integrate again 6. Okay, integrate from 0 to x 6 with respect to dx. So what we have is that gives us yx minus y0 equal to, integrate those, we got cx minus lambda integrate 0 to x. Alright, x minus t yt dt. Now how to get this? So basically we integrate. Once we integrate those, we got that yx d squared, and then we use the relation that I mentioned many times, right? So we have d integrate y dx squared and equal to integrate 0 to something. Yeah, let me recall those things. Alright, so we use the relation that integrate 0 to x y prime, this should be y prime yx yt dt, and this is equal to integrate a to x. General formula is this: x minus t n minus 1 over n minus 1 factorial yt dt. Okay, in order to get that from there, you integrate, then we need to use that formula. Then having that, we have y0 here. Why not? Y0 we have in the given in the boundary condition. Our boundary condition is y0 is 0, so we can apply that. That gives us, then using boundary condition 2, we have yx is equal to cx minus lambda integrate 0 to x minus t yt dt. Alright, now from there we can use another condition, yl. Given the boundary condition, the other boundary condition is yl equal to 0. Now you can use here. Again, I put it using boundary condition 2. In this case, boundary condition, we have y0 equal to 0. Now in this case, we use yl equal to 0. So using this, what we have is that substitute x and l, so we have yl is equal to cl minus lambda integrate 0 to l minus t yt dt. Okay, I think we use this equation number 6, number 7. Alright, or you can write this. We try to find c now. Alright, then write C, this is equal to, because YL is 0, so that equal to 0, right? So we can have C is lambda over L, integrate 0 to L, L minus T, YT dt. Alright, so this equation number 8. Now, if you use this C into 7, substitute there, okay? Substitute 8 into 7. Substitute 8 into 7. So what we have, just substitute everything in 7. So we have a yx is equal to, that gives us yx is equal to lambda over L, x integrate 0 to L, L minus T, yt dt, minus lambda integrate 0 to x, x minus T, yt dt. Okay, let's call this equation number 9. You can simplify those things. So what we have, just multiply the or bring the outside part of the integral into the inside of the integral. Then this equal to, we have integrate 0 to L, lambda over L, x, L minus T, yt dt, minus lambda 0 to x, x minus T, yt dt. Alright, and then for this integral here, because we have 0 to L, we split those integral 0 to x, x to L. Alright, so I can write this is equal to integrate 0 to x, lambda over L, x, L minus T, yt dt, plus we integrate from x to L. What we do here is that we split the integral from 0 to L to 0 to x and x to L. So the integral is still the same, x, L minus T, yt dt, minus lambda 0 to x, x tolak T, yt dt. Then you can rearrange this. That will give us lambda integrate 0 to x. So there's lambda, take it out. So we have x, L minus T over L, and then I think that one, okay, because there's 0 to x, so minus x minus T, all those things, yt dt. Okay, plus we have done that one, plus integrate x to L, we have lambda, x to L, x L minus T over L, yt dt. Okay, and then again rewrite this. This is equal to, we have lambda integrate 0 to x, simplify this term here, then we got T, L minus x over L, yt dt plus integrate from x to L, x L minus t over L yt dt. So if you recognize this is just the same as yx equal to lambda integrate 0 to L kxt yt dt, where your k xt is given as t L minus x over L for t 0 and x, and x t L minus t over L for t x and L. So this is the homogeneous Freedom integral equation of the second kind. Yeah, you can see that. All right, so this is the same as the homogeneous Freedom integral equation of the second kind. Okay, done. So what we did here is actually from the given differential equation, we integrate first, and then we have the term y prime in the equation. All right, then those y prime we let equal to some constant. Let's say y prime 0 equal to some constant, and then substitute into the what we have before that, and then we proceed simplify and so on, and then we need to integrate again to find, and then using the second boundary condition to find what those constants c is, and then the rest we just need to simplify. Okay, so that will give you the Freedom integral equation. In this case, it leads to the homogeneous Freedom integral equation of the second kind. So let's consider another example. Okay, so we obtain the Freedom integral equation, obtain the Freedom integral equation of the second kind corresponding to the following boundary value problem. Yeah. Corresponding to the following boundary value problem. So we have d 2y dx squared plus lambda y just equal to x for y0 equal to 0 and y prime 1 equal to 0. So let's give a name. This one we give number 1, we give this number 2. All right, and then you can write this equation. I think this is x, sorry, lambda y equal to x. Yeah, this is equal to x. Solution, you can write those as usual. Put it dy dx, d2y dx 2 on the left, and the rest put it on the right. So we have d2y dx squared that equal to x minus lambda y. Okay, and then we can integrate those things. Let's call this 3. We integrate 3 from 0 to x. Integrate 3 from 0 to x dx. So what we have is that y prime x minus y prime 0, that will give you on the right side x squared over 2 minus lambda integrate 0 to x yx dx. Alright, and then we don't have this condition in the boundary condition. Yeah, so then we let y prime 0 equal to c for c arbitrary constant. Right, therefore we have y prime x, this is equal to c plus x squared over 2 minus lambda 0 to x yx dx. Alright, and then for this limit of variable of integral, you can change those things, put x equal to t in that. So you can write this as a y prime x, this is equal to c plus x squared over 2 minus lambda integrate 0 to x yt dt. So what we do here is that just replace the or change the variable of integral. Alright, so then we integrate again. So this is 4, this is 5, right? Then we integrate 0 to x 4 with respect to x. So what we have is that yx minus y0 equal to cx plus x cubed over 6 minus lambda integrate from 0 to x. Again, we use the relation that I mentioned earlier. So we got x minus t yt dt. Okay, and since from the boundary condition this one is 0, alright, so what left is that yx is equal to cx plus x cubed over 6 minus lambda integrate 0 to x minus t yt dt. Yeah, since we use the boundary condition, from the boundary condition y0 equal to 0. That. Alright, and also we have the boundary condition y1 equal to 0. Okay, from the boundary condition y1 equal to 0, then we can have from 5, then from 5 we have so y prime 1 that equal to c plus 1 over 2 minus integrate 0 to 1. Okay, that one we have yt, that's yt dt. Alright, that's equal to 0, and from there we can write what C is. So therefore we have our C is equal to negative half plus integrate 0 to 1 yt dt. So we substitute this value into 6. Well, say this one 6. That's 6. Okay. We substitute C into 6. We have substitute C into 6. We have yx is equal to minus x over 2 plus s cubed over 6 plus lambda integrate 0 to 1 xt dt minus lambda integrate 0 to x minus t yt dt. Right? Or you can rewrite this or rearrange this. Again, the limit of integral 0 to 1. Now we split this limit into 0 to x and x to 1. Alright? So we can write this. We split the limit. Split the limits. So we have yx is equal to minus x over 2 plus x cubed over 6 plus we have lambda integrate 0 to x yt dt plus integrate x to 1 x yt dt and minus lambda integrate 0 to x minus t yt dt. Right? Then you can put this term together. So what we have now, this gives us minus x over 2. You can simplify those. So x minus 2, you can put it in one term, or you can write in as it is 6. Okay, so plus we have lambda integrate 0 to x, then xyt I think 0 to x xyt. We can simplify those. So no, just let me write just the simplified one. So we have x minus 2 x cubed over 6 plus lambda, we have integrate 0 to x tyt dt, okay, plus integrate x to 1 x yt dt. That. Okay, so this is the required Freedom integral equation of the second kind, if you recognize this, but with a split kernel. Okay, so the kernel is basically, this is what we have is this is yx is equal to minus x over 2 plus x cubed over 6 plus lambda integrate 0 to x 0 to 1 k xt yt dt, that where your k xt is equal to, we have t for x, t0 to x, for t0 to x, and it's x for t between x and 1. Okay, now from there we try to recover the original boundary value problem from this equation. So we do two ways in this example. Okay, now to obtain the given boundary condition or boundary value problem, the given boundary value problem, which is in the equation, from the obtained Freedom integral equation, we do the following. Alright, so we have 6, we have 7. Where's my 7? This is my 7. No, just a minute. Let me. Okay, this is 7. That's 7. And this is 8. This is 8. And this is 9. So because we need this equation later on to refer to. Alright, so we differentiate 7. So how to do that? First we differentiate 7. No, I just do it d dx 7. So we have this 7 is this equation here. Differentiate those. So we have y prime here negative 1 over 2, 3x squared over 6, and so on. Alright, so we have y prime x. This is equal to negative plus x squared over 2 plus lambda d dx. Integrate 0 to 1 x1 xy t dt minus lambda d dx. Integrate 0 to x minus t yt dt. Okay, you can rearrange this. That will give you yx or y prime x. This is equal to minus half plus x squared over 2 plus we have lambda integrate 0 to 1. You can perform this integral. So we have yt dt minus lambda integrate 0 to x yt dt. Okay, so let's call this equation number 10. Again, we differentiate that again. Yeah, differentiate now d dx 10. Okay, so what we have is that y double prime x, this is equal to I just write all this thing, x plus lambda integrate 0 to 1 del x. We have yt dt minus lambda integrate 0 to x del x dt minus lambda y x. Okay, rearrange this. We have or simplify that. We have this give you x minus lambda yx y double prime x plus lambda lambda yx. Alright, and I think from the given equation we have that's our solution. Yeah, d squared plus lambda y is equal to x. I think we don't have this. So can we check this? We have x plus lambda, then we integrate respect to x, that give you 0. Alright, and this we integrate that, d dx dt minus lambda. So we don't have this, so just x minus lambda y. So that one is 0, that one is 0, so x, so we don't have that. Alright, no, we don't have those. So that give you, from there we have y prime x plus lambda yx, that's correct, now equal to x. So this is the given boundary, the given equation in the question. All right, the given equation in the question. Now to obtain the boundary condition, where boundary condition, our boundary condition is y0 equal to 0 and y prime 1 equal to 0. So that's easy to do. From 10, you can obtain y prime 1. If you substitute everything there, that cancel out. That one is 0, that one is 0. Okay, so from to obtain the boundary condition, we substitute x equal to 0 and x equal to 1 into we have 7, you got the equation, okay, into 7, and another one is 10. All right, then that give you y0 equal to 0 and y prime 1 equal to 0. So we obtain the boundary value problem. Okay, we have the equation and we have the condition here. I have one more example but I think I just leave it to you as an exercise. Okay, I have one more example here, that d2y dx2 plus xy equal to 1 with the condition y0 equal to 0 and y1 equal to 1. So convert this equation, convert the boundary value problem into Freedom integral equation, and having done that, try to recover the given boundary value problem from the obtained Freedom integral equation. So I leave this to you to solve. If your obtained Freedom integral equation is correct, then when we reverse the operation to find the boundary value problem, that should give you the required boundary value problem. Okay. Looking for some exercise for you. Okay. Can you do this? Show that the boundary value problem. So we have y double prime plus ay prime plus by equal to 0 with the condition y0 equal to y, and y0 equal to 0 and y1 also equal to 0, where AB is constant. Show that this integral equation can be written, I would say, leads to yx equal to lambda integrate 0 to 1 kxt yt dt, where your kxt is bt x minus 1 plus ax minus a for t less than x, and bx t minus 1 plus ax for t greater than x. And add a little bit more, try to recover the boundary value problem from the obtained integral equation. Alright, so let's consider the end of this video. Let me recap the what we have done in this video. That's we given the boundary value problem, we convert into Volterra integral equation of the second kind. We convert into the Freedom integral equation of the second kind, and then from the obtained Freedom integral equation, we try to recover the given boundary value problem in the question. Alright, so the step is almost similar to the previous one. So I think that's all for this video. See you in the next video. Bye.